she's starting to get ready for next school year. And she's been looking through the leftover school supplies to see what kind of supplies she has that she can use for her class next year. And she saw a bunch of boxes of crayons. And she was noticing that the crayons came in lots of different sizes. And this is one of the boxes of crayons that she found. I want you to figure out, without counting one by one, how many crayons are in this box. Give me a thumbs up when you know. And you're going to take about a minute to discuss with your partner how many crayons are there, but I really want you to focus in on how did you figure it out? How did you figure out how many crayons are in that box? Is that going to change your answer? No, that's Ooh, and how did you figure out 8 times 3? Counted 8 3 times. Really cool. I heard such great strategies for figuring out how many crayons are in this box. So what we're going to do is I'm going to take some answers and I'm going to model your thinking in different ways of how you solve this. So I've got my chart here that says multiplication models, and I'm going to show your thinking in a couple different ways. We're going to use an open number line, a ratio table, a tile array, and an area model. Naraya, will you explain how you solved this problem? So we're going to listen in as Naraya talks. Naraya, how did you solve?
I solved it by, I saw 8 in the first rows, and I saw 3 more, and I saw 2 more rows in the back, so then I did 8 times 3.
Awesome. So she saw that there were 8 crayons in each row, and when I was talking to Naraya, she told me that she was counting by 8s. So she went 8, 16, 24. What equation could I use that would represent that thinking? What equation could I use? Go ahead.
8 times 3.
I could write 8 times 3 because we have 3 jumps of 8, or I could write 3 times 8 equals 24. Really cool. And then I was talking to Robin, and he got the same answer, but he thought about it in a little bit of a different way. Robin, will you share your thinking with us?
So I did 4 plus 4, then not 4 plus 4. I did 8 plus 8, and then I got 16.
Mm-hmm.
And then I added another 8, and I got 24.
So he was thinking about this problem like 8 plus 8 plus 8. And I'm going to show that thinking on a ratio table. So he thought about each row having 8 crayons. So in one row of the box, there were 8 crayons. In 2 rows of the box, there was 8 plus 8. There were 16 crayons. In 3 rows of the box, Robin figured out that there were 24 crayons. Really cool. Thank you for sharing. The equation was, and I'm going to model your thinking using some tiles. Okay. Talk to me about what did you see in that box of crayons?
I saw that it was 8 in each row.
Okay, so I'm going to pause you right there. Can you let me model that really quick? So she saw that there were 8 crayons in each row. So I'm going to take these linear pieces and put 8 of them across. 1, 2, 3, 4, 5, 6, 7, 8. All right, really cool. And then how many rows were there?
There was only 3 rows.
There were 3 rows. Okay, so pause for just a second and let me show that too. So this right now shows 3 by 8. I want you to quickly talk to your partner, and if I filled in all of this space with tiles in my 3 by 8 array, how many tiles am I going to have? And tell your partner how you know. Go.
Well, I'm going to put those tiles down. I would put square blocks on here, all of them to fit in.
All right, so I built that same problem. This is just like our box of crayons, right? We have 8 crayons in each row, and there are 3 rows. So how many crayons do we have? Go ahead and share. We would have 24 crayons because we know that 3 times 8 is 24. So I'm going to of crayons, Miss Wingo was going through her supplies and she noticed that she had other boxes of crayons that weren't the same size as this first box that she found. She found this box of crayons. Now I know it's really tricky to be able to see all the pieces here, so I'm going to tell you that there's still 8 crayons across, but this time there's 6 rows of crayons. It's okay if you haven't finished, but I want you to finish solving with your partner and talk about how are you figuring it out. Go. Solve this.
So what I do to solve this is I go by, I count it by 21, by say 25, 26, 27, and then that would be my main.
So this box has twice as many as the last one. Last time we had 24 crayons, and this one has twice as many. Could you figure out how many that would be? Talk with your partner, see if you guys can figure it out. If this box has twice as many as the first one, how many crayons would it have?
2 times 2 is 4, so that would be 48. Twice as more. I know 8 times 5 equals 4. But we're doing 8 times 6, so I did 8 times 5, then I did 8 times 6, 48.
That's so cool. So you knew that 8 times 5 was 40, and then you needed one more group of 8. Really cool. I heard some really cool strategies that had to do with looking at rows and columns, and I also heard some really cool strategies that had to do with the idea of twice as many. So what I'm going to do is I'm going to come right back to this multiplication models chart, and I'm just going to add to your thinking here.
I got 48.
You got 48, and one of the things I heard you talking about was skip counting. Were you doing some skip counting in there? No, maybe it was someone else then. You were skip counting, right? All right, talk to me about your skip counting.
So what I did to do it by skip counting was I counted by 6s because I feel like that's more easier. So I said 6 times 1, 6 times 2, 6 times 3, 6 times 4, and I stopped all the way at 6 times 8 because when I see the crayons in columns and rows, I know it was 6 in each of the 8 rows, and I know it was 8 in each of the 6 rows.
Really cool. So she liked counting by 6s, so she went and counted by 6s and made that count 8 times. I'm going to take that same idea, but I'm going to add to it when we started skip counting by 8s and just keep extending our number line here. We could keep counting by more 8s. So I've made this this jump of 8, 1, 2, 3 times, and I could do it 3 more times to make 6 jumps. 32, 40, 48. And we can also see that we've now doubled it. We've made that 24 2 times.
So what I did to get 48 is I made an array. I did 6 columns and 8. I did 8 columns and 6 rows.
Awesome. I'm going to pause you there for just a second, and I want to model what you just said. So she was working with this tile array on her paper, and she knew that this time there were 6 rows, so she had to add some more. She did another set of 3 so that we had 6 rows this time. All right, you keep talking, and I'm going to fill this in as you talk, okay?
So, and then me and Kylie had went and counted them to make sure that we had the right answer. And then on her paper, she had put 24 times 2 because 24 times 2 equals 48 to make sure that we had it right.
I love that. So you expanded your tile array to now make it 6 times 8. Before we had 3 times 8 is 24, and now we can see that 6 times 8 is 48. We're talking about kids in a class where they have tables, and their tables have letters. At table E, the kids have 9 pencils in the supply box that they share. The kids at table F have 3 times that many pencils in their supply box. How many pencils do the kids at table F have? All right, go ahead and get started. You can solve with your partner. pass these two down to the rest of your row for me. Thank you.
What we can do is, so what I'm going to do is add another, I'm going to make columns of 9, and I'm going to make rows of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we can use the number on it. Count, if you get count by 9, you can get to 27 by counting 3 times, or you can count by 3.
Okay, really cool. So if they had like 1 time as many, they would have 9 pencils. Okay, so what does this mean? When they had
2 pencils, that means that they had more.
is this pencils over here?
This is how many. Like, they had 3 times as many.
Oh, okay. So
I wrote 3.
that's really cool. Okay, so you said that this shows how many times as many. Okay, can you write that down on this side, times as many? And then what are these numbers? What do those represent? The number of what? And I'm gonna have some kids share what it is, the model that they use to show their thinking. And as each student is sharing, I want you to think, how are these models alike? And how are they different from each other? All right, I want you to look at all 4 of these models. And I want you to think, how are these the same? And what about them is different? Take about 15 seconds to think first. All right, talk to your partner about your thoughts. Go.
But they're just different problems. Like they're different strategies that you can use. And it's different because they use different strategies. You count 3 times. You count 3 times. That's basically the answer.
What's the same about all of these models? What's the same about all of them? Kenneth?
What's all the same is that they all have the same numbers and they all equal the same sum.
So cool. I heard that from so many groups as we were coming around. They all have the same numbers and they all get us to the same answer. What's different about these models? They do not all look the same. What's different about these?
What else is different about them is that they all have different ways to get in the answer, to get in the product of 9 times 3.
Oh, I love that. So she said these are all different ways we can model our thinking of getting the product of 9 times 3. Okay, so today we solved multiplication problems using 4 different models. We used the open number line, we used the ratio table, we used a tile array, and we used an area model. And we're going to keep using those models as we work through multiplication situations all year long. So I want you to take a minute to think, why do you think it's important to know more than one model that can be used for multiplication? Talk to your partner.
More than one model for multiplication because you might be uncomfortable with one model. So if you do another model, you feel more comfortable with that one. And also the problem may not be like fitting for the model that you're using. So that's why it's important to hit the
What would make it easy? Like, if you had something that was not a known fact, would you want to try the area model? I love that. So if it wasn't a known fact, you might want to do a tile array so you could like count or add to figure it out, right? Well, what did you and your partner talk about? Why do we have all these models for multiplication? Why is that helpful? I was talking to Roland and we were talking about if something wasn't a known fact for you, maybe the area model wouldn't be the one to pick, but you could use something like a tile array so you could check your thinking if you weren't sure about the answer to something. Go ahead.
So if you don't know one way, you can use other ways to get an answer.
Yeah, we could use any one of these models to get to the same answer, and if there's one that you're less comfortable with, you could choose one that's more comfortable for you, or something that more matches the problem that you're working with.